Okay, I'm not live yet, which is mildly terrifying. Keep refreshing my page until that happens. Awesome. I can hear an echo. It took a second. I'll probably ask again. What does elbow cough signify? I've never understood this. Santosh, or what does this emoji mean? Um, Welcome back, everyone. Thanks for joining me. This is a part of the Kaggle study group. We go through top solutions. This is a part of the H2 AI community, and the forums I've been mentioning for a while are live now. So if you'd like to be part of the forums, just to stay updated on all of this, you can sign up at this link, community.h2.ai. We'll be going through the feedback three competition, and we'll be understanding the competition and then the top solutions. So what we do every week is we gather and I try to explain the top solutions. So usually the first half of these live streams is understanding the problem statement and the competition and some general tricks around it, and then we go ahead and try to understand the specific tips and tricks used by top teams. So our goal every week is to learn what the top teams use. This was an NLP competition, and it was a third feedback competition. We've covered both. Actually, by the end of this live stream we'll have covered all three. This was a text regression problem, text multi regression if you want to be specific, so we'll be learning all about that. One quick announcement. Starting next weekend, I'll be starting a study group or live stream for this book as well, Deep Learning by Ian Goodfellow. And I couldn't find the book, but one for Hugging Face one as well. So you could again just join the community to stay updated on it, or you could subscribe if you want. You'll just be notified. Both of these study groups will start next weekend. So just wanted to announce that quickly. Awesome. So what I wanted to start with first was head over to Kaggle, and if you'll ignore my extremely low rank, I wanted to point out that one of my colleagues, absolute legend Philip Singer, has reached rank number one uh, with this competition. We'll be covering his solution as well, but he's back on top. He was number one again, and for some reason he was bored, and he just casually decided to become number one in competitions again, and he just spent 2 weeks on this competition, as he told me. I have the fortune of having a few meetings with him every week, and just in 2 weeks he finished fifth. So we'll be covering his solution as well. And one of my good friends as well from Kaggle, Emerd, has finally reached the competition grandmaster status. So I was really happy to see this. I interviewed him a while ago for, I think it was his feedback first solution, and at the time I was telling him that he'll become a competition GM this year, and I'm really happy that he did. So congrats to both of these guys, and now we'll start with the regular live stream. So I thought it'll be more interesting to start this way. The main difference between the first feedback and this feedback is, if you will indulge me, if you'll just give me a few seconds of reading this text. This is so boring. Twinkle twinkle little star, how I wonder what you are. That girl cannot sing, like, oh my gosh, that girl is like a cat dying. I have no idea what this means, but the first feedback was about helping very young kids, so like are under around the age of mid school, third grade, I think. And for this competition, here's an example of like a perfectly scored. So these are like two extremes, but this is an example that we had to work with. And as I read through it, you can read through it, you can pause the video and go through it. I won't pause more than this. But this, I don't think I am capable of writing this well formed essays. So as you can see, the students have grown up. The quality of their submissions has gone up, and the goal of this competition was to help assess the language proficiency of 8th to 12th grade ELLs, English language learners. And the idea is that using this, we can help improve the automated feedback tools. So, presumably, these are in low resource countries where students want to learn English. And if we can develop these techniques that can be really helpful to them, we can probably automate the process and give them this feedback through a model. Crowdog, I see a legend in the chat. Crowdog, he says nice hoodie. I'm sure he'll get his own soon. So thanks, Andrea, and thanks for joining us as well. His team, as I said, finished third, and we'll be covering his solution as well. I asked him if he'll join the live stream. He said, "Go away. I have more important things to do." So that's what he thinks of me. Anyways, so this time it's a multi regression problem in the sense that the essays have six analytic measures. So you have to understand how cohesive are their argumentative essays. So the one I just showcased a second ago, if you read through it, it was quite cohesive. And then you have to see, is the syntax well formed, is the vocab good enough. Now, how do you evaluate good enough, right? For all of these things, there are scores from 0 to 5 with gaps of zero point 0.5. So that's how you are provided with those scores. It's of course a supervised problem. uh, how well is this phrased, the grammar and conventions. um, this is also terrifying for me in the sense that Kagglers keep improving and maybe students keep improving as well, right? Like I don't remember my essays being graded so strictly. Like I would just get one score out of 10, and that by itself was challenging for me. Anyways, so these scores, sorry, they range from 1 to 5 and in increments of zero point 0.5. So your task is to predict the score of each of the six measures. And one more interesting thing this time was there was an efficiency track as well. So this was to see how can you score really high in a shortest time span, and this was run on just CPU. So usually on Kaggle, your submissions you're allowed to train your models offline, and then you upload them to Kaggle where you have to run the inference in some time constraints. For efficiency, it was just CPU bound. Finally, the evaluation criteria of this was similar to root mean squared error. It was actually mean column wise root mean squared error, since it's a multi regression problem, as I mentioned earlier. So, since Philip became number one through this competition, like number one again, I thought we can use the tool he's created just as a baseline. So, what I did was I loaded up this data set. I see Aman Kapoor in the chat. Hey, Aman, thanks for joining us. Aman also ranked pretty high in this competition, right? If I remember correctly. I remember chatting to him in some competition very recently. So let me share my screen, and I'm using Hydrogen Torch just to evaluate what can be a quick baseline. And this tool, as I said earlier, was made by the best of the best. Philip Singer, Yawen, Babakin, Chishin also shipped a few updates. So what I've done here is I've loaded up feedback price, this latest problem, and framed it as a text regression problem. And as you can see, this is a pretty small data set, right? It had, as it was showing earlier, as the tool was showing earlier, there were 3,000 examples or so. Aman's team finished eighth. As I remembered correct. So congrats again on the gold. I'll hopefully, I'll definitely cover your solution as well today since you joined us. Hopefully, I try to cover 10 solutions, top 10. Usually I struggle with doing all of it, but I'll definitely cover your team solution. So as I mentioned, there are six criterias with the following scores. And then you have the complete text, which is the essay. And you have about 4,000 or so examples of these. So 3,911. And you can see the mean scores and the general distribution over here. So what I want to do here is I want to create an experiment. I'll say I'll probably be daring enough today because I've been doing this for a while, and I'll switch the experience level to master. And I'll probably set this out on group K fold for 5 folds. And what I'm trying to showcase here is it's also fairly easy to use no code tools like this to get a really good baseline. I'll probably have to ask Philip if he uses this for baselines. He probably does. It's already detected the following label column, so that's all set. and we'll use the entire data. There are no separators, so we'll skip that. I'll probably use lowercase, yes, please. And we can set the max length to 512 for this experiment, sure. We can set the padding quantile to 9. And for backbone, I think I'll use Roberta or maybe Deberta base. Deberta is one of my favorite models. Deberta is every Kagler's favorite models, right? Um, I think I'll skip dropout. And Philip, in his solution, mentioned gem pooling is his favorite pooling layer, so we'll use gem pooling for this. And as you can see, like in just a few seconds, I set all of these things up. I'll probably also use differential learning rates, yes, and use a cosine learning scheduler. Train this for 3 epochs, maybe. Um, and just like that, I can kick this experiment off after setting the loss function. In the background, this will kick off, I think, all 5-fold training. And I've done that already. And as you can see, it took about 15 minutes to get all of these baselines. And with this tool, I could really quickly iterate and benchmark all different ideas without even having to do much. So if you want to try this, there's a free 14-day trial. I'll just share the link again if you're curious. I see Nishchay in the chat as well. Nishchay tried this jacket last time we met, and it didn't fit him because he's still waiting for his solo gold. So I hope you get that soon. I'll keep teasing him until he becomes a grandmaster. He's a good friend of mine. Um, and here's the link to sign up for the free trial. If you're an academic user, you can just sign up, and you can of course use it for Kaggle if you want. So as we saw, we got around 0.52 validation score for root mean squared error, and we had used this Deberta base. So now what I want to understand is what's the difference between that 3-minute baseline and what the winners had done. So we'll start going through all the top solutions, and I'll probably give some more context before that. Uh, this is emotional damage. Um, Yeah, I think probably the day he becomes a grandmaster, he'll show up at my door and start like screaming or doing something crazy because I've been teasing him for so long. Um, I wanted to showcase some EDA, but the main thing to point out here was for some labels, as you can see, the distribution it's like a normal distribution, but for vocab and I think there was one more label where the extreme ends or some scores were lacking examples. um I think we'll come across that again, so I'll probably skip this. But as you can see, most of the distribution is normal for all of these examples. Zoom out and start going through all tabs in sequence. And one more thing to point out, we're doing this so early that the winning team is still waiting for their winning prize. So this competition just ended 5 days ago, and I'm happy that we were able to get to it super fast. So continuing in sequence. Also, I saw someone. I was curious if anyone has, and I am curious if anyone in the chat has bought a 4090. But someone was flexing their 4090 subtly because they were pointing out that it's been a struggle to set up CUDA and PyTorch. So I'm curious if anyone in the chat has done that. And I'm just sharing some more background drama and story around the competition. But this might tell you that some people were unhappy, and they were unhappy because of this. So this is a shake-up visualization, uh, private rank versus public rank. As you can see, there was one rank in gold which shaked up from 500, 500, 500, 500 position to gold. Oh, welcome back, Rashmi. She says she's set up a 4090. And does that work well with the latest PyTorch version and everything? I'm guessing it does because you did mention you were able to set it up. Um, that's another flex there, people. I just bought two more 3090s. I'm very happy with that. Um, had to say that. So as you can see, there was quite a bit of shakeup for all the high-ranking teams, and that also caused a lot of memes. The thing to point out here is, if you look at the first three digits or first two digits, it's the same score from first position right up until where my team was, 0.439. And between thousandth position and first position, it's only a difference of third digit. And why is that? Because again, this was an NLP competition, yes, but the data was really small and the number of examples were incredibly small. So this was somewhat expected for everyone setting up. Rashmi says it worked for feedback 3. I'm curious, where did you finish on the leaderboard? Because I'd love to cover your solution as well if you've written it. And if you could please send the link to that. Not PyTorch 2. PyTorch 2 just the nightly shipped, I think 2 days ago, right? I'll probably try that out myself and share my experience. But that's interesting to see that these are working really well. Thanks for that. K Killer is an absolute legend for all Kaggle competitions. And they've shared some general tips on NLP. So what they suggest is NLP is mostly dominated by transformers, and Deberta is usually the best. That's why it's my and most Kaggler's favorite model. So his remark is most SOTA models are very effective, and you should spend less time looking for best model. There is a tiny edge to get from optimal model searching compared to data modeling. You should cover a few examples, and he suggested the following. I've only heard of Deberta, Electra, and Longformer, T5 as well. So maybe Funnel, Co-column, Luke are worth trying. And he says usually base or large are ideal candidates. And again, he emphasizes spending time on data modeling is much more rewarding than spending time on architecture search. And finally, do it yourself. Don't just look at kernels because there can be some faults, some mistakes. Oh, sorry, I didn't realize that. So Rashmi and Aman were in a team and they had finished eighth. Congrats to both of you. That's awesome. I don't understand why such high ranking Kagglers join my live streams, but thanks for joining. I don't know what you can learn from me. We're here to learn from your solution. Um, and it should make you more cautious and focus on writing code when someone says something doesn't work, because this is one thing we've observed in all of the previous live streams, right? Between all the top teams, someone would say something didn't work, and the team just above or below them would say yes, it worked for them. So it's just about experimenting and seeing what works best for your setup and figuring out how to make it work. So that's what K Killer is saying here as well. So this competition started with, as you might expect, Nakama. Nakama writes incredible baselines and very neat and absolutely legendary code. So he had shared this Deberta V3 baseline that everyone started building off of. And as I pointed out earlier, the LB was just stuck. So it was just 0.43 from top to bottom. And now we're trying to now we'll slowly start learning how the difference between these thousand teams in the third digit exists. So here's a guide to tokenizers and pre-processing as a quick refresher. Uh, for tokenizing, you can basically use these 4 lines of code where you just load a tokenizer from auto tokenizer and you pass in the name of the model you're working with, and that'll take care of everything. This returns your inputs IDs, token type IDs, and attention mask. And then you can feed these to a Hugging Face model. Uh, Many legends usually also dive into the tokenizers working, and you can also look into how they work, and you can also introduce special tokens like classifier and separator. So earlier, very quickly, as I had shown in hydrogen torch, you could also fiddle around with these settings while working there. And many people in the top teams have done that already, so we'll start going through that. There are some other strategies you could. It's similar to images, right? Like, so my camera is pretty solid on point right now, But otherwise, if I was using a low res cameras, you'd see the black bars, right? So in images, that's black padding or like 0 pixel padding. In text, you can do similar padding, or you could do dynamic padding. So that means adding padding tokens to shorter sentences. Basically, if your sentence is short, you add some padding tokens. You could truncate a longer sentence. So you could. I'm trying to draw analogies to images, but basically, you could crop into an image. And finally, I was reading a question. I have a really hard time understanding any top solution code, to be honest, even if I spend time with it. Any suggestion how to make that more effective? It's supposed to be hard, right? Like many people spend months after having years of Kaggle experience. So I think there's no easy way. Just like spend more and more time with it. Ask the winner. Uh, Ask them. Usually they're very open to like pointing out what didn't work, and many times people clean up their code, but it's still like it can be cleaned up a bit more, or it's somewhat cryptic. So it's like it is hard to understand all of that. Wouldn't you want to summarize text on truncating sentences to reduce loss of info? My guess is since you have enough examples, it's okay to like lose out on one or two, but that's just my guess. Maybe you could like that's again an idea you could try uh, and see if it helps. I don't know if anyone has ever done that in a competition. If they've not, there's your idea to like push yourself above these teams. Max length is a parameter that is used to control the length that's essentially fed into the transformer model. So when we talk about max length, it's about how much of the sentence you feed to the model. Crodoc is sharing some legendary advice. He says, try to go with simpler code examples. Top solutions can sometimes be more complex. I was thousand and my solution can also be complex given the code we were writing. Actually, for this competition, my teammate and I didn't participate properly because both of us ended up traveling. But like it's true for many of us. But like people like Yakama and Chris Diot, many of my colleagues at H2 write incredible clean code kernels. I know Crowdog had written one kernel recently. So I would say like go to kernels of such authors, right? Because like they are well respected for a reason because they write like such easy to understand stuff. Good luck for reaching the expert title. You already have one medal, and that's awesome, Andrew. So good luck for that. Crowdog says always check notebooks from Chris Stewart. I agree with him. There's also normalization, which is a pre-processing step built into many tokenizers. It performs general cleanup such as removing needless white spaces, lower casting, and removing accents. One thing to pay attention when like they were saying that you should deep dive into a tokenizer, you should make sure you understand if you're normalizing your sentences, right? Because sometimes you might want to keep that, and that might help. So again, you should be careful. There's pre-tokenization as well, which I'll skip. Then there are the following four types of tokenizers. I'm not sure if there are more, but these are the ones I know. Byte level encoding. This splits a word into characters and applies the merges learned during training. Word piece. It finds the longest subword starting from the beginning, then does the same for the rest of the word. And the best way to understand these is just like tokenize a few sentences and print out things. That's like the easiest way to see what's going in and coming out of the model. But this is like just an overview. There's Unigram, which splits into tokens using the scores learned during training. And then there's finally sentence piece, which addresses the issue that not all languages use spaces. So if you're working with, let's say, Chinese script or I'm not sure if Chinese does have spaces there, right? I don't know. Maybe some language that doesn't always have spaces to separate words. Uh, you'll probably use that there. Uh, One of the young legends, Vadim, had shared this kernel, so I'll probably use it. It's titled "Optimization Approaches for Transformers." So we'll go through these, and the reason again why I'm spending time on this instead of straight away diving into the solutions is because these are relevant to that. We'll see these terms pop up there, and I'll just summarize them ahead of time and some more so that like we can only cover what's necessary. So this is just like the prelim knowledge required to understand a lot of things. But here he shared some ideas for optimizing transformers. Here's the overview. So you can use gradient accumulation instead of calculating or doing a backprop every epoch. You can do that every few epochs, and what that helps you do is that helps you fit your models on your GPU, which can be a problem for especially extra large models. Andrew has a comment on spaces. So Chinese does not use spacing between words, but syntactically the structure is clear. Word order is more flexible. Thanks for that. I didn't know that. So maybe sentence piece then makes sense for Chinese, I guess. I was trying to think Hindi, but Hindi use spaces. Hindi or Devanagari script uses spaces between words. Shreya says this notebook was really helpful. I agree. It's a really nice notebook. You could freeze layers. So usually layers close to input have learned most of the structure. So ideally you can freeze them. There's automatic mixed precision. Basically, if you're using a modern GPU, being after 2015, you can use FP16 and that can speed up compute. You can use 8-bit optimizers to speed things up. CrowDog, I remember when I teamed up with him, he kept saying that this was his favorite approach because in one of the competitions, it gave him a large boost. And it did not work for AI for code, which was sad. But this is one of his favorite libraries. So I'm sharing a secret from him if you'll allow that. You could use gradient checkpointing. I assume everyone knows that. You could use fast tokenizers. Then you could use dynamic padding or uniform dynamic padding. So that's just the overview. I assume everyone knows what last 3 points are. So I'll skip those. So these are the optimization approaches for transformers. And here are some more. This notebook is by Torch, and this is titled "All the Ways You Can Compress Transformers." So I'll remember to upvote both of these, which I'd forgotten. Sorry about that. Please always upvote notebooks and discussions you find necessary. People share them after a lot of efforts, and it takes hours, sometimes weeks, to come up with them. So for me, I upload them and I have to remove the upload for the live stream just to use that as a reminder. I see a question. What kind of pre-processing or pre-tokenization tends to work well? Um, I can talk about pre-processing. Some straightforward ones are you could just convert everything to lowercase. So I toggled the switch while the quick demo because I wanted to get to Kaggle. So I rushed through the demo. But in Hydrogen Torch, you can just like convert everything to lowercase. That's a pre-processing. For example, in AI for code, we tried one thing. So for AI for code, you were supposed to rank Jupyter Notebook cells, and we basically CrowDog came up with this idea of randomly sampling cells. That I think that experiment went really well. So it really depends on the example you're working with. And he says 8-bit Adam rules. I think it's still his favorite, one of his favorite techniques. So this notebook teaches us all the ways you can compress transformers for reducing model size and increasing speed. So this is again mixed precision. You could use knowledge distillation where you efficiently train smaller student models to mimic the behavior of expensive teachers. So essentially, you have a bigger model that you train, and then you distill the knowledge of that into a smaller model. So basically, the smaller model with a slight accuracy hit gives a performance boost. So maybe you have an extra large model that wouldn't work in the constraints. You could condense that, or you could distill that, sorry, you could distill that knowledge into a smaller model, and that would work in the constraints. You could prune non-essential portions of a network. I personally am yet to learn how to do this. So if anyone knows, please share any resources for this. Um, Dynamic inference acceleration. I'll have to go down to this. I don't remember how this works. Um, and there are few other techniques. So matrix decomposition, this is well known. There's operation fusion, so numerical tricks to merge nodes and graphs. I don't think this works well for NLP though. And then there's module replacement. So you could replace some layers, I assume. Let's scroll to inference acceleration because I don't remember that. I think this is quite complex to immediately read. So I'll probably cover this in the next live stream. But okay, that's one technique that I did not know of. This was another baseline that helped people get going. And I know many top teams have used this. So Chris, absolute legend, had shared this starter pack. And he says this is similar to Pet Finders competition. So Jiba, who's also a Kaggle legend, had won that competition. And what he did was he extracted embeddings from not fine-tuned models and then trained and predicted using the concatenated 10,000 columns of embeddings. So this worked really well. And this notebook is similar to that. So this achieved 0.45 score without fine-tuning any transformers. The notebook simply extracts embeddings from Hugging Face transformers and trains a SVR head on top of it. So you can imagine many people tweaked this and, of course, optimized it as much as they did. The CV strategy by most other teams was multi-label stratified k-fold. Um, if you want a quick refresher on cross-validation techniques, Rob Malla has this absolutely awesome video. And as you can see in the suggestions, I've been watching all of his videos and they're absolutely awesome. Um, but if you want a quick refresher, go to Rob Mueller's channel. And as you can see, I've like watched it. That's why it loaded mid screen. But it's called Complete Guide to Cross Validation. Highly recommend his channel. Generally speaking, you'll learn more there from than you learn from me. Um, okay. Continuing further. And this was a general discussion. So as you can see, 3 months ago, people were hovering around 0.44. And as I showed later on, it basically converts to 0.43. So everyone was hovering around 0.43, and then it was the third digit optimization that it boiled down to. Okay, I'll continue further. So a few more baselines. Nishad also shared a PyTorch Lightning baseline, and he had shared how to use stochastic weighted averaging callback, iteration-wise validation. For NLP, CrowDog taught me this. But if you validate multiple times inside a epoch, that's also a good strategy because most of the times these models converge in 2 or 3 epochs. Uh, he was a polynomial scheduler. I think that was intentional because maybe he wanted to use the cosine. He wanted to keep the cosine for himself. That's one of the most popular ones, right? Um, and he had trained on a smaller length and larger during inference. Okay, some more tips from general discussions. Don't forget to use right strip, which basically removes the right and white spaces when using long former. Otherwise, you would run into these exceptions like this person did. like Takamichi did. Um, Here are a few text augmentation suggestions. I have written a blog on this paper. It's actually called EDA, Easy Data Augmentation. So you could have random swapping of words. You could replace words with their synonyms. You could randomly delete words from sentences, or you could do back translation. So Jesse, I think he used back translation, and what this does is you take a sentence, translate it to another language, then translate it back to English. And because how much of a slight difference occurs when you're doing that, that slight difference is good enough to use as an augmentation for most of the language models. Crowdog says he also used polynomial schedulers. Maybe I've been using the wrong scheduler all this time. You didn't teach me that thing when we teamed up for AI for code. We were using cosine, I think. I don't even remember what we used there. Okay. And here is a quick summary from during the competition. So this person, Jiang, read through discussions and he learned the following things. So you could experiment with CLS or mean pooling, which one is better. Multi-label stratified K-fold, as I said earlier, was best for this competition. You need to use layer-wise learning rate decay, and you have to use layer-wise learning rate decay and last layer reinitialization. And many people also use pseudo labeling from the previous competitions. So here was the discussion I was alluding, pointing out to earlier. Um, Model can only predict in the following range or 5 out of 9 labels, and it has challenges in predicting labels, the following labels: 1, 1.5, 4.5, and 5.0. Since it's a normal distribution, right? It's challenging to predict the like initial and last uh, numbers, since it goes from 1 to 5 and it's a normal distribution. These examples are slightly less, right? So there's a question: what's the purpose of last layer reinitialization? I assume it works really well for fine tuning. So from what I know, many people pre-train this, pre-train their models on the older feedback competition, and then fine-tuned it. So they downloaded the model which had been trained wherever these models are trained, Reddit, internet, Wikipedia, whatever. Then they pre-trained it on the previous feedback, and then using that model weight, they finally fine-tuned that on this competition. So I assume maybe some people kept all of the layers frozen for that, and the last layer was unfrozen for this fine-tuning approach. Okay, so now we can start going through the team's solutions. I have given all of the context and we can start learning through them. So this is by the first place, and this was a team of three. Um, their solution is based on training lots of different models with different pooling techniques and max lengths, and finally ensembling. They also use three models to extract embeddings and add them to ensemble. So what I pointed out earlier, the trick that Chris had shared, I think that's what they're referring to here. So instead of using not fine-tuned model, they did fine-tune it, and they did extract the embeddings and then ensemble it. Many people actually did this in the top teams. So they say they had nearly perfect ensemble CV and LB correlation. And for splitting the folds, they had used multi-label stratified K-fold strategy. I think Abhishek had shared this uh, kernel that helped everyone get started with multi-label stratified K-fold. So that's it. That's why, and everyone stuck to it. Um, their final solution is a combination of different modeling approaches. Please, I actually went through the solution discussion and I learned PL means pseudo label data. So they use a train plus pseudo label data, train or pseudo label data with different pooling techniques, and they play around with the max length. So for Deberta, they landed with the following lengths and 512 for others. Then they froze the top end layers. And just to point out path, here's where it worked really well for them. They reinitialized top layer or sometimes did not. They sometimes, I think for all these experiments, they use differential learning rates and finally use adversarial weight perturbation. This is a regularization technique, in short, if you don't remember. So next they point out what they use. So different pooling layers were used: mean pooling, concat pooling, weighted layer pooling, gem pooling, LSTM pooling. And mostly, basically, three Debertas and a Roberta large and distal BERT was used. For extracting embeddings, they use BART large, Roberta large. Um, I was just reading through this. I think it is Roberta large and BART large MNLI. For weight tuning, they used Optuna to tune the model weights. Since they use different folds for training, they use final out of folds to tune the weights and also tune the weights. Also, weights are tuned target wise. So I believe they, for the pseudo label data, they extracted all of the predictions and then added that to the data set while tuning it for the final values. I hope that made sense. They only add a model to our ensemble, to their ensemble, if it improves both ensemble CV or LB. The best CV they got was 0.44, and the second best was 0.440. Next, they share all of their examples. I'll skip through this and you can go through that list. They also notice that generating soft or pseudo labels on trained data leads to huge overfitting. So for pseudo labeling, they used feedback one competition, trained data, and mean of trained pseudo label and actual labels. So for they share the things that worked, and augmentations and post processing did not work for them. They have also published their inference code, so you're welcome to go through that. I'll probably skip that. So just to summarize, they used an ensemble of the following models, and the main source or the main trick was having a different and very nice healthy ensemble with the following techniques. I assume the detail that's missing here is also key of how they pseudo labeled feedback on competition and how they involved that. But that's for someone who wants to replicate the solution to figure out. Um, for the first team, augmentation did not work, and for Jesse, his solution is titled back translation, so it I think worked very well for him. So he says his best was with pseudo train and Optuna. And I'm just quickly reading through this. My personal best one is one without pseudo train and no Optuna tune. And then he says the scores for them. Then he tested pseudo and hand tune rule. I assume by hand tune he means he manually tuned the models. So these were not very stable, and he was afraid that he might have been overfitting. So the best single model was around 449 without pseudo train using back translation or feedback to pre-train. So by this, Jesse means that he had downloaded feedback to's data, pre-trained the model on that, and then fine-tuned to this. And the best model with pseudo had the falling score. Next he shares the backbones that he had tried. So Deberta V3 large, Deberta V3 base. Only the two worked for him. All others were worse. And he says to do I should have added SCR method ensemble. For training, he used a max length of 1280, which is different to what we've seen, right? Usually it's 768, 512. This was the first time I saw 1468 as well. But this is the first time I'm seeing 1280. Some details around batch size. He used linear learning rate decay and AWP training for the last two epochs. For back translation, he pre-trained only two epochs without AWP. Finally, he submitted 23 models into two. So 23 full trained models, 23 models trained on fold 0 to 4. And this took 2 hours. So he had you have a limit of 9 hours, and this just took 2 hours out of that. So because the data is so small, you can submit so many models and still get away with that, right? Another contrast example, different example would be AI for code, where we participated and we could only fit three models in the limit. So I think we had Deberta large and base, maybe two variations of base. I struggle to remember, but like that was a large data set. So since this is a small data set, you can see the numbers are pretty large here. What works? Let Bird deal with the target relation, adding Pearson laws, using back translation for pre-trained. So this is again one of the tricks because he used a lot of back translation in the following languages, and I only understood a few of those. So I assume this is like the standard when you load them up, right? EN is English, and all of these are French. This would be, I don't want to guess, so I'll skip. CY could be Chinese, I'm guessing, maybe. So he says notice back translation data is only used for pre-training for two steps. And second step is the same for all models. Then he used feedback two data for pre-training. So the first position team used feedback one. Second position solo gold use feedback two. And then pseudo labeling works. So pseudo labeling plus Optuna is much better than no pseudo plus Optuna. And then tuning for each target. I think I wanted to point out something else from the comments, but maybe it was for the third team. So this was the second position team, and the sauce or the trick here was back translation for a lot of languages, along with Optuna based tuning, and then adding Pearson laws is what I understood were the like key tricks. Third position, Santosh is asking what is full train model. So I assume when instead of training on folds, when you train it on the entire data set, that's what Jesse refers to full train. I hope that makes sense. Um, the third place, and this was Crodog and Ahmed and Christiot. So this led to Ahmed becoming a competition GM. Their solution is an ensemble of 24 models without using pseudo labels. Most models use Deberta V3 large backbone and a variety of tricks. The ensemble was chosen using hill climbing. And hill climbing is basically adding models consistently until it stops adding, until you run out of the inference limit or until those models stop helping with the score. And if you look up on Kaggle forums, you can find a nice description by Chris himself on what is hill climbing. So you start with this. They started with a single model with best CV and iterate through all other models and pick a second model which helps the most. Then you pick the third until the models do not help. We allowed hill climbing to use negative weights, which boosted CV. Um, Philip, in his discussion, actually pointed out that he was scared to use negative weights, but then he realized he should have, because those would have helped. So the third team actually used negative weights when ensembling, and here's a pseudocode. I think it's actual code of how they did this approach. Um, each day they train new diverse models, and then they ran hill climbing to see if the new models gets chosen. We don't need to make a new model with great CV score. We just need to make a new model that is diverse. So that was the key to their solution. Below are the choices in order which hill climbing picked from their 50 models. Hill climbing chooses diverse models and not the best CV scores. So Deberta V3 large, it's quad 2. Uh, I assume this was initialized slightly differently, hence the difference. MNLI, again V3L, XLM, Roberta large. So as you can see, they ended up using 24 models with different, slightly different approaches. Are there, when I say are, it's for them, right? Um, Crodog says negative weights was pure magic from Chris. I I'll try to pull this up, but during, I think the gold medal, the one gold medal that I have on my profile, we that was the first time I used negative weight ensembling, and we named that uh, Black Magic. That submission was called Black Magic because that gave us a huge boost, and I remember like being so surprised by it. But it is Black Magic, and I'm sure it was magic from Chris. Um, There's a question for CrowDog. Stride window was that to accommodate more than 5 and 2 length? I assume yes, maybe. I'll let him clarify. So for tricks, their models use a diversity of regression heads, pooling techniques, schedulers, and backbones. Then they share these in detail. I'll glance over all of them. I'll let CrowDog clarify about stride window. Um, for models that didn't support training on more than 5 and 2 length, you would have this sliding window, and let's say you can only fit one word, right? So you would have this window where you fit in yes for models that basically you do that in like lengths of 5 and 2 to like fit the data into the model. So that's how you use the stride window. Since Deberta, again, this is where like this is a difference between top of the line teams and us, right? Like, or me. Let's just say me, because we have some legends in the chat today. So I would probably skip over such details because I wouldn't even like dare to look inside the tokenizer. But this team actually looked inside the tokenizer and they learned that Deberta ignores backslash n on new line token. So they replaced it with double backslash. So they replaced double backslash n with the following. So this is a way of telling your model that hey, this is something, and then you can let attention and all those like black magic things figure out that this symbol means a new line. This team actually used last layer reinitialization, and they use two-stage pooling. First pool either words, sentences, or paras, and then the result. Maximum training length was 2048, and for inference it was 640. Deberta was trained on 2048, CrowDog mentions. Rapids SVR use embeddings without training on competition data. Their final submission does not use pseudo labels, and they tried using pseudo labels during the competition. They were careful to avoid leaks, but nonetheless, pseudo labels from feedback one boosted their single model scores. Awesome. That's the third position solution. And since I promised Rashmi that we'll get to the eighth team, start. I'll continue further. This is the fourth place solution, and it's a stacking of 22 models. All models trained in this competition are the same folds, so four folds, and they had 38 models with max length of 5 and 2. Deberta, Albert, BART, Electra, GPT, etc. Uh, this goes through the SVR method and ridge regression. This heads down to the final blend. Then you have the following models being fine tuned, I assume, on one of the older competitions data. And then you fine tune with pseudo labels the following models. So as you can see, some of the old models directly head to the ensemble, some of the fine tuned ones get furthermore trained. And then you fine tune this further with more pseudo labels. So for all of the models are then fine tuned further into a blend with more pseudo labels. And these are the final three models that they are fine tuned with. I'm just glancing over the names because you can actually pause and go through the solution if you'd want. But again, just by reading the names, it's not really helpful, right? You have to like actually experiment. What's like key here is they're like fine tuning in multiple steps, in my opinion. Finally, for stacking, they use the 22 models painted in red, and then they add some readability features. This goes into uh, ridge regression for selecting, I think, or the weights. And you also use the OOF predictions for light GBM. And finally, you do a weighted average, which gave them the private score 433. What worked? Train SVR or Ridge using pre-trained model embeddings. So this team actually used pre-trained models instead of not even training them, extracted features from last four layers, and used forward selection to explorate the best SVR. Sorry, I correct myself. This is what is happening here. So here the embeddings were being extracted and selected through feed forward feature selection, not just the model outputs straight away. Sorry about that. Next, they used high impact was pseudo labeling, pre-training with pseudo labels and fine tuning with only the given train data, concatenating pseudo labels with given train data and training all of this. So they use feedback one data and use only feedback one data similar to feedback three. They don't share how they selected this. This is again a key detail that's missing, and you might have to experiment and figure out how they did it. Finally, they use ridge and LGB stacking. So they use ridge, trained a ridge regression model using the predictions of fine-tuned models as input values, and LGB model using the predictions and meta features created by readability. Sorry about that. They also added a backslash in. I assume this is similar because they also discovered the same thing about Deberta. And then they shortened the sequence length. This was low impact, so they only used 512 length for reducing inference time, I assume. And they did train a few models with 1500 length. I'll skip these details because they've been covered. What didn't work? So for them, AWP did not work. Train SVR using fine-tuned model embeddings did not work. For the first three teams, last layer reinitialization worked surprisingly for them. It did not work. Predicting punctuation errors and using their stats as a meta feature. That's such a cool thing to do, right? And it's like I would basically give up if that didn't work. And surprising they continued regardless. Um, just as a heads up, we'll go 15 minutes overboard today because I want to like cover more solutions. I made that promise and I'll stick to it. So please, if you'll spare me 15 more minutes to cover these solutions, and I'll try to cover them the best I can. Um, predicting the quality rating of discourse elements and using their stats. That's again such a cool thing to do, right? It's surprising they continued. So that's the difference between top teams and us, or me, just me. I'm sure other people tried hard. Fine tuning spelling correction as a convention specific model, and fine tune pre-trained weights from top solution. Uh, that's it for the fourth place solution. And now we come to the new king of the leaderboard, Philip Singer's solution. He's the new number one. There was a celebration inside us too when that happened. Actually, not really. It was just like another day because this is the second time he reached number one. Um, but no, I'm sure all of us were really happy to see him back on the top. And I'm thinking maybe Chishin might be the next number one. Who knows? Who knows? Maybe Crowdog will be the number one in 1 year. I'm sure of that. That would happen maybe in a year or two. Um, so for Philip's solution, his solution is an ensemble of multiple fine-tuned NLP transformer models. Additionally, he employed 2 rounds of pseudo tagging on old feedback data. So he followed his own solution. Team Hydrogen with Yawen and Philip had won the previous competition. And basically, in 2 weeks, he got to fifth position with the solo gold. Uh, and that too working across both tasks. So I'll cover both of his solutions, but he spent half of time. So basically, if you like boil that down, uh, Philip spent 1 week and got a solo gold in this competition. I spent I could spend an year on a competition and maybe get a solo silver at best. That's the difference between legends and I'll say me because I know many good people are there in the chat. In general, he observed very good correlation between local CV and public LB. So he used the metric as RMSE. He trained 3 unique seeds and always only compared the average of these 3 seeds. So if he wanted to compare the following learning rates, he would run for each of those 2 experiments 3 separate seeds for a single fold. And only if the average improves, he would run on all 5 folds. So for modeling, he fed in the text to transformer model, applied some pooling layer, added a linear head, predict regression targets, and for that, the following token lengths were used. And the following models are trained with dynamic. All the models are trained with dynamic padding. For pooling, he'd used CLS token and gem pooling, and the following backbones. He usually run 3 epochs for most of the models with cosine decay learning rate, always picking the last epoch, using differential learning rate and the head of the model. He did not use differential learning rate and reinitialization. Finally, all models are pre-trained on full data for final submission and also blended some fold models as lots of running time was left. So for pseudo labeling, second feedback competition was used and 2 stages of pseudo labeling were used. Train an ensemble only on trained data. Run the predictions on previous feedback, excluding this competition's data to avoid any leaks. Use pseudo labels from this extra data set and apply it to modeling with pre trained models and fine tune it on the training data afterwards. This was repeated a few times using an ensemble trained on pseudo labels. For the ensembling, it was just seed averaging. The best sub is a NM optimized ensemble of models, where the ensemble weights were separately optimized per target column. And he, as I pointed out earlier, said that he could have used negative weights, but he felt it was quite risky, so it skipped that. For the second position, augmentation worked, but for Philip, it did not work. Different losses did not work. Jesse figured out how to make Pearson loss work. TF-IDF did not work. Other backbones didn't work because Deberta was so strong for this approach. and second stage model didn't work for Philip. But as you just saw in like the one position above this, they use a multi-stacking approach, right? And that worked really well. So I think it's like it finally boils down to, like, as you can see in top five teams as well, there's so much variation that you could try any approach and land pretty close, right? So it just depends on what approach you're taking. And like all of these are absolutely legendary approaches, right? So I'll also cover Philip's efficiency solution. I tried to find other solutions from the efficiency track, but I could only discover his. So um, I don't know if Rashmi or Aman, you have written about your solution on the efficiency track. I can also cover that. Or if CrowDoc, you've written about your solution. But Philip says his final submission was a Deberta V3 small distilled on pseudo labels from old competition, and he used Onyx for speeding up inference. For knowledge distillation, the main approach of pseudo labeling is described like so. He generated pseudo labels for the previous feedback using the ensemble after two rounds of previous pseudo labeling, generate OOF pseudo labels, and then combine these two data sets and train a single new model without any labels. Fine tune a final model with low learning rate on actual labels, continuing from these pre trained weights. And then he shares how to make this work with Onyx runtime. For this, he had pre tokenized all text and exported this to an Onyx inference code, which ran in about 18 minutes. Um, if you feel bad about selecting wrong submissions, even the legends can mess up, right? So I remember Philip mentioning this during a call, uh, but he could have placed third, I think, if he changed a few things. So quantization and different Onyx backends didn't work for him, and Hugging Face Optimum library was also tricky to use for him. CrowDog says he had a Deberta V3 small, but it wasn't optimized, and it was 2x slower, but had a good score. Okay, thanks for sharing that. We'll cover the sixth position solution, and I'll probably wrap up around the 10th position solution. So Tom says the correlation between six classes was quite high in his baseline models. So he tried to relax it and created models for each class, which he calls separate models here. He also trained single models, but with separate heads, and in the end, his solution is a class wise weighted average of four separate models and five single models, where he used GP minimize function from scikit optimize to determine the weight. So he ended up using 30 models and it took around 1 hour submission time. So I have all of these separate models and these single models going into a class wise weighted average that led to the final solution. AWP did not work, pre training did not work for him. Pseudo labeling did not work, random mask augmentation and second stage stacking did not work for him. I'll skip the sixth position efficiency and try to cover the accuracy track. But I'll recommend this solution as well to everyone because this was quite complex and interesting to read through. So if you have the time, please uh, go through the sixth position one as well. CrowDog says, so nice of Sai to share the Onyx exporting in such detail. I agree. Um, I think it's worth making a separate video by itself. And I can do that as part of my work, right? Sorry for thinking out loud, but I know what I'm doing next week now. Uh, I'll probably have to trouble Philip. Seven position solution. They say they still can't believe they shaked up to goal zone. The final ensemble is a collection of 16 models, and these are selected using needler meet method. The default parameters are 512 AWP, which starts at the third epoch, and they've shared some hyperparams of how that works. BCE loss, and they freeze layers of the large models for the first and second layers, and for extra large models, 3 and 4 layers are frozen. Um, they use FP16 and 5-fold. Next, they share all the models that they've worked with. AWP was high impact, but it didn't work for public LB, so they did not add to the ensemble. I don't know what LWLD is. Does that mean layer wise learning rate decay? I'm guessing. Um, Needler method BCE and freezing layers was low impact. So for them, second stage models, last layer initialization, and FGM did not work. Okay, I've decided to skip the efficiency track. Sorry about that. Just to make sure I can cover the accuracy ones. Next, the eighth place solution. This was a collection of 26 models, including knowledge distilled and pseudo labeled ones. Ridge regression was used to integrate the prediction of each model. Post processing was applied to adjust the output value. So, this is the first solution, an hour into the live stream, we've come across that uses post processing for this competition. So even they landed the same technique of replacing backslash and backslash and with paragraph. And the third position just put a pipe there, but you could also put a paragraph label there. For single model, the following techniques contributed to the score. Next, they share individual details about all of these models, which I'm going to skip. But few things to point out: for one model, they use LSTM plus mean pooling. As you can see, some models had different max lengths and training with decreased max length later on. For some, they use the CLS token, mean pooling, uh, pseudo labeling, and for this one, they added no paragraph. This is the first time I'm seeing Coco LM in this competition. Many other models had mean pooling, and some had pseudo labeling, some had stochastic averaging. I'll skip pre-processing because I already covered this. Knowledge distillation, they had one Deberta V3 extra small with knowledge distillation. They decided to distill knowledge out of whole data from an ensemble of 9 models and utilize these to train the model, utilizing only current competition and not previous competition. Pseudo labels, this was challenging to determine if pseudo labels are working or not. They generated labels with a few different models. Eventually, 2 seeds of Deberta V3L were created, which was more stable for them. Model architecture, just CLS token mean pooling plus CLS, mask added attention head, CLS. They tried all of these things. They use ridge stacking. I'm skipping a few details for stacking the model. And these are two Deberta large models with different seeds, which combined generated one ridge coefficient and help an ensemble. For post processing, they used NM method for post processing, divided predictions into 20 bins, and multiplied the resulting array with predictions. This was based on second place solution from CommonLit. For them, MLM did not work. Other models, I'm assume they tried a lot, did not work. Focal loss, asymmetric loss, ordinal regression did not work. And ensembling with weights did not work for them. That was the eighth place solution, and I forgot to upvote, so I'll remember to upvote that. There are two eight places. Oh, this was this was the teammates part. Sorry about that. They share some details about how they made pooling layers worked and how mask attention head was added. a few tricks around how to train Electra and how to use concatenate pooling. So this has been published in a notebook, and I'll request you all to go through that. Finally, we get to the ninth place, and I see someone's spamming in the chat, so I'll quickly remove that. Aman says Rashmi is one model with two seed itself landed them to the gold. Uh, I would expect that from your team because I know you all have been doing really well on competition. So congrats on that. Congrats on the amazing gold finish as well. Vadim says nice hoodie. Thanks, Vadim. I expect Vadim would be wearing his hoodie as well while joining the live streams, right? Finally, we reach the 10th place solution. So the quick summary is they used a blend of two submission files, which was an ensemble of three Debota V3 base models, trained in PyTorch and using pseudo labeling to improve the results. These models were based on knowledge of previous feedback competition. The second one was an stacked ensemble of 22 models. And for this, they use iterative stratification and set the folds to 4 and seed to 42. They set the OOFs based on model trained with Deberta V3S, two models on V3 base, and different models with different backbones. They used a couple of transformers without training and just extracted, I assume, the embeddings and uh, trained simple regressors on the vectors, on the embeddings, I assume. Finally, a lasso regressor was trained on the OOFs. Next, they shared how these scored against the leaderboard, which I'll quickly skip since we're quite over time. And I think I can, since Vadim is in the chat and he's asking me to cover his solution, so I'll honor his request. Um, Vadim, should I cover this part or the solution part? I assume this is your team solution, correct? Yep, I recognize the icon. So I'll quickly cover this since we have a young legend in the chat. Their solution was a large ensemble of 30 models with various heads, optimizers, and backbones, different hyperparameters, MLM pre training. This is the first time I saw MLM pre training working for someone. Pseudo label configuration and SVR and ridge models similar to Chris's approach. They tuned 6 groups of ensemble weights, one per column. This allowed them to train single label models or models trained on a subset of the label. They trained many additional models, but only kept the ones that helped in the ensemble. So I assume they also used hill climbing. Pseudo labeling worked well for them, and they also created synthetic data. So they trained a T5 base to complete essays and included the first N words. This is pretty cool to see. They use many different pooling layers, including Con Bundy, which I haven't seen earlier, many different backbones, single label and subset label models, and different hyperparameters across these. Vadim worked on many alternate pseudo labeling approaches, but that did not work. Focusing on a single strong model did not work for them. And they tried adversarial training approaches, but that did not work well as well. Okay. Awesome. I'll wrap up here. I'm just catching up on the chart. Um, Aman, I did not realize. I thought Aman was already a master. Aman is a recent master, it seems. Let's see if I can find his Kaggle profile real quick. Um, Sorry, I'm stressing out because we've gone over time so much, right? Um, Aman is ranked in top 500 at this point, uh, and I'm sure he'll keep climbing further above on the leaderboard. But as you can see, he's now a competitions master. Congrats on that, Aman. And I don't know what Crowdog is talking about promoting, so I'm sorry if I missed that context. Okay, thanks for joining, everyone. I'll remind you all to check out the H2AI community. If you've made so far into the live stream, consider subscribing if you aren't already. This is just for the community, and I'll keep doing this for as long as I can because I personally enjoy learning with everyone. Um, and next week, as a reminder, I'll be starting a study group for this book and the Hugging Face book sometime around that. I'll also start covering research papers now very soon. So, don't know how soon I'll start the research paper, but those are the things I've been working on. And since I'm finally back in my cave, you can expect more and more content. So thanks for joining me on a Sunday. We'll meet again next week. I'll cover competition similar to the RSNA one, and we'll keep learning together. I'll see you all next week. Thanks for tuning in.